the next pattern that we'll look at is composite. Okay, so composite is a way to if you use any like PowerPoint or any graphic software, if you can group something and then use that, move objects around and then group that objects again. This is exactly the result of the composite pattern. Okay, the idea is that if you have some objects and you would like to group them into another object, and then that object can also be grouped with other objects to obtain the object itself again. Okay, the idea is that you have a component class, and then you have a composite class that can contain other components as its children. Okay, when you apply some operation on the component, if it's a component, then it actually perform that operation. If it's a composite, then it would apply that operation to its children. Okay, so here in our code of Flappy Dot, if you remember, we have this pillar pair. Okay, the way we implement the pillar pair previously, we have this image. Okay, the top and the bottom pillar, and we use that to create a sprite. Okay, we'll change it here so that we will split it. Okay, so we use two sprites this time. Okay, one is a pillar top, another is a pillar bottom. So we're gonna have two sprites object, and then we will group them. Okay, and to create a group, we'll use the composite pattern. Okay, to do that, in our game lib, look at our game lib. We have class game canvas element. Okay, so we're gonna create a composite from that can contain any game canvas element. Okay, so to do that, so let me make a copy here. So we'll call it element group. Okay, or you can call element composite, but let's call element group. Okay. And then when you create it, it just doesn't do anything much. Okay, but it would contain this list, a list of children. Okay, this children set is something that you can add. Okay, you can add children into this element group. Okay, when you add an element into this element group, then you can say, like, if you hide this group, then you hide everything in the set of the children. Okay, here if you write the composite pattern in Python, you don't need this big the parent class, because in Python the subclass system is like you can apply anything to anything if it's a duck type language. So you don't need the class hierarchy like that. You can just create a class element group this way. But if you use other languages like C++ or Java, then you need to first create a common superclass, and then let leaf and composite be a subclass or an inherit from that component. Okay, so in Python you don't need that. Okay. Okay, so this self.children is something that we would do here. So when you call a show on the element group, we just apply the operation to all its children. Okay, when you call high on this group, again we will say c.high. Okay, the harder thing to do is for render. Okay, so this init element and init canvas, we just leave it there. Okay, so when you call render, what we would like to do is that this element group can move, right? So if you move an element group, everything inside this group should move at the same place. Okay, so so element group has an x and y. We would interpret the x and y of this element group as the location of the whole thing. Okay, but when you group element into this element group, okay, when you group other elements into this element group, these element can have location inside this group. Okay, so they also have the children of this element group can also have x and y of their own. So the actual location of x and y of the element group's children would have to be relative to the location of this element group. Okay, think of it this way. So let me show you the picture. So let's look at the pillar pair. So if you look, we have two sprites here. Okay, when we group them, we would like it to be like this x here, this location here is the location of the element group. Okay, but the actual location of the sprite is up here, right? The center of the sprite is up here and the other one is up here, is down here. So so when we add the element to the element group, we would probably the top pillar, the location is gonna be up here. Okay, its x location, the y location, the y location of the top pillar is up here, and the y location of the bottom pillar is down here. But if we move the location of the x and y of the group, the whole pillar pair has to move all together with it. Okay, so when we can do something like this. We can just say if cell is visible, then for c in self.children and c.render. We can just do that. Okay, but then it's not going to be enough, because you have to be able to say to move the elements. So when you render the thing, the element is rendered with basically the game canvas element here. It says it actually sets the coordinate of the canvas object. Okay, so now we should have some mechanism so that we can move the whole object by an offset. So what I would do is that I would say so I'm going to add two arguments here. So offset x with the default value of 0. This is fairly technical, but it's understandable now. Offset x plus. So when I actually set the location, I have this offset x and y. Okay, that if you don't pass the offset x and y, just display the object at the same location. But here we would use x and y of the group as an offset to render the element inside the group. So we would say here render function would take offset as well. Because a group can be inside another group, so the offset should be accumulated. So okay, so this is the rendering function. Okay, so so now we actually move everything with the group, and we have the group. Okay, we can add a children. Basically, we can write a function that deal with the children, but in Python we can just manipulate the children itself. If later on we would like to work a little bit on the children, we can just use property. We can create a property in a class so that we can deal with the change of the children later on. So so let's leave it there for now. Okay, in Java you need to create a function called setChildren, and so that you avoid actually changing the children directly. Okay, now the pillar pair is not going to be a sprite anymore. It's going to be the element group. So we need to import it. Element group. Okay, and when we init element, we would just create the two sprites and add it to the children. Okay, so we say cell.top pillar. It's going to be a sprite. Okay, sales dot you're going to create a sprite, right? So so you need to be able to pass a game app to the children, so we need to save so we need to save the game app as well, because when we create a sprite, we need game app, right? So that's why we okay, that's a thing that we need to fix our game lib as well. So game app. And then images pillar top. Now the location of the pillar has to be the relative location of the pillar to the group. Okay, so so let's look at here. The pillar has the size of the image on the pillar is of size now. So, okay, the actual size of the pillar here is I think 800. The height is 800 and the width is 880. The width is okay, because the center of the sprite here is going to be the same as the center of the on the X location, it's going to be the same as the center of the group. But then we need to add the height of this. So the middle of the thing is 400, and then we need to the space here to be like 200 pixels. So we add another 10. So we should say 0 and 500. So let's see that. Okay. And the bottom pillar, it's gonna be this should be minus 500. This should be 500. Okay, and then we say cell.children append bottom pillar, like that. Okay. And let's see if it works. It works the first time, would be great. Oh, okay. Should take oh, okay. So now when we create a pillar pair, we don't need to put the image anymore. Okay, just add the location. Okay, now it works. Oh, it's too high. Maybe the height of the image. Maybe it's 600. Okay, so let's okay, looks okay now. Right. So let's fix the thing a little bit so that we make sure everything works. So let's increase the pillar speed a little bit so that okay, we'll do so let's say if the pillar reach the other edge, it moves back. Okay, so if cells.x less than the width of the pillar is 80, so this less than 40 minus 40, then say cells.x equals canvas width plus 40. It's moved back. Okay, so let's make sure that it move up. Okay, so by random height, let's random the thing a little bit. Let's say that range. Oh, we need to import. So let's run it. Okay, it moved down. Random. Okay. Okay. So now the it should go up, right? Oh, okay, like that. Okay. So that's the composite pattern. Okay. Basically, we have a children, so it's here. Okay. So we leave the init canvas object and init element out, okay? Because if you inherit this, if you want to create an element group, you can modify the init element here itself, or you can just the way we use the element group here is that we inherit from this group. Okay, we can also use the element group directly here and let the element group be the pillar pair be just an element group at here, and then we can just add element to it, right? But because we want the behavior of this pillar pair to be we want to modify the behavior of the pillar pair, so we don't use the element group directly, we inherit it and then apply use add children to it and then change the behavior of the group, the whole group. Okay, all right, so that's the composite pattern. Okay, the next pattern that we would like to take a look is decorator. Okay, decorator is a pattern that allows you to add functionality to an object at runtime. Okay, you can add you can decorate the object with the operation, and you can add more and more operation to an object. Okay, this decorator thing is going to be really close to another pattern called the chain of responsibility. So when we look at the chain of responsibility pattern, you see that it's extremely close to each other. They are very similar, but the purpose of the pattern are slightly different. So when you look at it, it should be you can see that when learning about pattern, you don't need to actually remember all of this. Okay, you should kind of vaguely recall that you can use this and that, and then when you actually need to use the pattern, you can just look it up. Okay, and if you use it, if you are more familiar with it, then you remember the pattern anyway, right? All right, so the idea is that you have a component with some operation. Okay, but you can decorate that operation with a decorator. For example, you may have a notifier object, and then you want to be able to notify the user from SMS and Facebook and Slack. Okay, and then you want some user might want to be notified on Facebook and also on Slack. Then you can have this hierarchy, which are pretty crazy like that. But now if you apply the notifier right here, you can decorate the notifier with this decorator, so that it's actually combine functionality. Okay, like here, when you have a notifier here, and then you can apply more and more decorator, so that it would do something like combined functionality like that. Okay, so you shouldn't confuse this with the decorator of Python. Okay, it's extremely close with this, but Python is decorator in Python is a way to add functionality to a function or a class or something like that. But this is the decorator pattern. It's very when you applied it, it's kind of like very close to each other, but very similar, but don't confuse with that. Okay. All right, so for the example code, we will look at you shouldn't get confused with this decorator with the Python decorator. Okay, in Python you have decorator as well. Okay, you can like add functionality to function using the syntax of decorator like this. Okay, but it's kind of close to the decorator pattern, but they're not the same, exactly the same. But all right, so let's see the example of that. We'll look at the Pac-Man code here. Okay, recall that when Pac-Man eat a dot, okay, we would like to in the assignment you need to implement the observer. Okay, so we will do similar things here, but with the decorator pattern. So when the Pac-Man eats a dot, so let's call self dot notifier, which is none. Say empty. So you can have a none here. So let's say we have empty notifier. Okay, so this empty notifier just do nothing. Okay, class. Okay, so when it's got to be notified, someone would call notify function. So we say self dot notifier dot notify, get notified. Okay, here. Now if you want to do something more with the notifier, we can apply the decorator patterns. Okay, so we can say class score notifier. Okay, again in Python you don't need a class hierarchy, so so you can just leave it there. So but if you really want to make sure that all this class has the notified method, you can say you can create a class hierarchy here. Okay, so an empty notifier will be just a notifier and it doesn't do anything. Okay, okay, just like the class notifier. Okay, you can in Python you can also enforce the fact that your class has to implement that notifier is an abstract class, so that nobody would be able to instantiate it with the abstract class thing. But you can look it up. We probably look it up in the assignment. Here we just leave it there for simplicity. Okay, so instead of using the empty notifier, you can just use notifier as in the example in the refactoring guru, but I don't kind of like it because notify is the base class and I don't want to use it. Okay, so let's have an empty notifier like that. Okay, so for score notifier, when it got notified, it would basically do something, and then let's say print not eat. Okay, E10, just like that. Now if you now when we do this, we can have a notifier that can do one thing, right? An empty notifier, it won't do anything, right? A score notifier would just print a .e10. Maybe you want to have a super Pac-Man status notifier, like if the dot is super dot, then you change the Pac-Man so that it's becomes super Pac-Man, right? So, or you do that at random, right? But now just print something. So if you have a notifier one kind, it actually does only one thing, okay? But you want the notifier to be so you want the notifier to be able to decorate each other, okay? Like add on each other. So we will do something more, okay? So we create a hierarchy like that, okay? And then self dot, no, sorry. When you, so on the constructor, we take a parent, okay? When you got notified, okay, basically you would do this. You would just if check if cell.parent, you would do your job and then you look at the parent, okay? Then if you have a parent, then you notify the parent as well. Okay, that's the notify thing. Okay, now when you implement notified here, after you finish doing something, you check if you have a parent. Okay, then you say parent. Okay, like that. All right. You can see that that's a duplicate code here. We'll fix that later, but let's see how this pattern actually works. Okay. So you have an empty notifier that does nothing. Okay, you have a score notifier that when you have a score, and then the parent would, you just print this .e10, and you have super Pac-Man status notifier that actually print this thing. Okay, so on the Pac-Man, initially you have empty notifier here. Okay, let's say we want to, for Pac-Man 1, .notifier, we would just add the .notifier. What's the name of that? Score notifier. So we would just change the notifier to be score notifier with the, but we need to pass the parent like that. Okay, for Pac-Man 2, let's say it has 2 notifiers, so let's say and super Pac-Man notifier. Okay. You can see that when I add a decorator, I keep adding on this as a parent. Okay, so the Pac-Man 2, the final dot notifier is going to be super Pac-Man status notifiers, but this notifier has a parent, which is a score notifier, and that score notifier has a parent, which is an empty notifier like that. So let's run the code. So let's move the first pacman. Oh, parent is not defined. Oh, okay, so we have a bug here. Oh, we add self.parent. Okay, both of them etom dot, so we see dot e10 and super pacman here. So let's see the second pacman, the first pacman. Let's move. You can see that it only say dot e10. Okay, but the second pacman just print two things. Okay, both. Okay, the first pacman just dot e10, second man like print two things. Okay, because the hierarchy of the decorator pattern that we have here. Okay, now you can see that when you call notify, you need to add these two lines, and it's extremely buggy if you want to do that. Okay, so but you can just do this. Okay, you just do this. This is like when you call super.notified, it just call this notifier. Okay, so it checks the parent and it call the parent notifier itself. So like this. So this would be a simpler way to do that. Okay, so let's run it. Let's try to see if it works. Oh, okay, so okay, so it's simpler this way. Okay, but again, you might be forget to call the super.notified. Okay, so the way to get over this is that instead of letting the decorator itself call this, we just add we tell the person who would like to implement this to actually implement this function instead. Notify. Okay, and then we do something here, and then the notify function we just call here, and then just call parent notified. Okay, so here we just write the code, and we don't need to call this. Okay, in the decorator classes we implement do notified, and the decorator mechanism for calling the parent is already coded in the notified. When the people call notifier, they call this function on the parent class that would actually call the do notified and call the parent. So this one is going to be easier to use. Okay, exactly same behavior. Okay, but you don't have to be careful to call the parent. Okay, all right, so what we've just done here is exactly not exactly the decorator pattern. The decorator pattern is here. Okay, you have a set of class that decorate over each other like this. Okay, but the way we allows each notifier to just implement do notified, and the mechanism for calling the parent is already inside the base class. This is called a template method. Okay, so it's another design pattern that I've just applied. Okay, so template method is it's now we start to look at behavioral patterns. Okay, the template method is this one. The template method look at allows the base class to specify some default behavior, or maybe actually default non-behavior here, and then the subclass would modify the behavior of this method, and then the actual call to this method has been done in the base class. Okay, it says, okay, if you want to modify the element, do it in the subclass. Okay, so this is called the template method pattern. Okay, so it's exactly just this. Okay, so that's exactly what we just done. Okay, here's the template method. Okay, so they have default implementation, and then on the subclass you actually change the things that you really need to change. Okay, so this is the template method pattern. So there are three other behavioral patterns that we'll look at. So we'll look at that in the next clip.